Okay, so we're going to look at this method. We're going to kind of review what we did in class today, solving by elimination. So remember, I'm basically adding one equation to the other with the goal of eliminating either the x or the y. To solve an equation, I need to only have one variable in it. And you can see each equation here has two variables, an x and a y. So this first one, if I add the equations together, first I add the x's. So 2x plus 3x equals 5x. Then I add the y's. Negative 1y plus positive 1y. Since those are opposites, like we talked about, they sum to 0. So it's plus 0 equals, but I don't need to show the plus 0. So now I just have 5x equals. And then on the other side, I add negative 2 plus 17. So that's like 17 minus 2. That's going to be 15. So my new equation is 5x equals 15. So x will be equal to, if I divide both sides by 5, I get x will be equal to 3. So that's the x coordinate of our solution. Oh, whoops, I'll write it over here. And now to get the y, I can pick either equation. So I'll pick 2x minus y equals negative 2. I'll take that first equation, and I can plug the x into it and then solve for the y. So then I have 2 times 3 is 6. Then I'm going to subtract 6 off both sides. So on the left side, I'm left with these sum to 0, so I'm left with that negative y. Don't forget the negative sign. Negative 2 minus 6 is negative 8. Then I'm going to multiply both sides by a negative 1 to get rid of that negative sign. I'll do it this way. In front of the y. So negative 1 times negative y is positive y. And then negative 8 times negative 1 is 8. So the y coordinate of our solution is 8. Remember, we can always check our solutions by taking each equation and showing that this point satisfies each equation. So I'll start with the first equation. If I plug in 3 for x and 8 for y, I should get a true statement. 2 times 3 is 6. 6 minus 8 is negative 2. It is a true statement. Therefore, the point 3,8 lies on the first line. Now I'll go to the second line. 3x plus y equals 17. So if I plug in 3 for x and 8 for y, I get 3 times 3 is 9. 9 plus 8 is 17. I get a true statement. So the point 3,8 lies on both lines. Okay, let's look at the next one. If I were to add these equations together, I would get 1 minus 2. I'd get a negative x. And if I add these together, I get a positive 3y. And then if I add the 9 and 8, I get a 1. And my goal is not accomplished. I made a new equation, but I did not eliminate one of the variables. The goal is to get rid of the x or get rid of the y. So in this case, we had to multiply one equation times a number before I add. So if I want to get rid of the x's, it would work. Since this one is a negative 2, I need this to be a positive 2. So that means I can multiply this whole equation by positive 2. So I'm going to rewrite my system. 2 times every part of this equation. So I have 2x plus 4y equals 18 over negative 2x plus y equals negative 8. Now, when I add these two equations together, my x's are eliminated. And I have 4y plus 1y gives me 5y. And then 8 plus negative 18 is 10. So I get y equals, I have to divide both sides by 5. And I get y equals 2. So for my solution, I got the y first this time, which is fine. And now I'm going to choose that first equation, x plus 2y equals 9. I'm going to plug the y in. So x plus 2 times 2 equals 9. So I take that 2 and plug it in for y, and now I can solve for x. So x plus 4 equals 9. If I subtract 4 off both sides, I end up with 5. So x equals 5. So then that's the solution. You would put 5 and 2 into both of these. So x plus 2y equals 9. Negative 2x plus, do it this way. Put in 5 for x plus 2 times 2 for y. So I get 5 plus 2 times 2 is 4. 9 equals 9. That is good. I get the second equation, negative 2x plus y equals negative 8. I plug in the 5 and the 2. Negative 2 times 5 is negative 10 plus 2. Negative 10 plus 2 is negative 8. Checks out. So it checks in both equations, which means that point lies on both lines. That means it's a solution. Sometimes we have to multiply both equations by something. When I see like here, I want to eliminate, let's say, I want to eliminate the y's in this case. Multiplying something by 2 to get 5, I can do it, but it'll be a fraction. I don't necessarily like to do that. So I think of a number that 5 and 2 both divide into the smallest one, and that's 10. So I want to make both of these 10, and one of them positive 10, and one of them negative 10. So if I multiply the top by 2, that would make a positive 10y. I'm going to think ahead here for a second. If I multiply the bottom by 5, I'll get a negative 10y. Then these will eliminate because they will be opposite. So that's why I chose those numbers. So I'm going to rewrite my system, multiplying by the 2 to every part of this first equation. So I get 4x plus 10y equals 90. Here I'll multiply the 5 to each part. I get 15x minus 10y equals 100. Now I can add these two equations together. And I get 4x plus 15x is 19x. These eliminate, equals 190. So now I have an equation with just x in it. If I divide both sides by 19, I can get the solution. X equals 10. So there is the x coordinate of the solution. Now I need the y coordinate, so I'll choose 3x minus 2y equals 20, and I'll put 10 in for x and solve for y. So I get 30 minus 2y equals 20. So then when I subtract 30 off both sides, these eliminate, and I get negative 2y equals negative 10. I divide by negative 2, and I get y equals 5. So there's the y coordinate. So I can check by plugging into both equations. I'm not going to go ahead and do that. You can do that on your own. Here, again, I want to eliminate the x's and the y's, the x's or the y's. I'm going to eliminate the x's here because I know I can make both of these 15. But one of them needs to be positive and one of them needs to be negative. So I'll multiply the top one by negative 3, so I'll make that x a negative 15. And I'll multiply the bottom one by a positive 5 to get a positive 15. So negative 3 times 5x would be negative 15x. Negative 3 times 4y would be negative 12y. And then negative 3 times negative 14 would be, let's see, 3 times 14. A negative times a negative is a positive. Be 30 plus 12, I think it's 42. And then 5 times 3 is 15x. I'm doing this one down here. 5 times 6y is 30y. And 5 times 6 equals 30. So now when I add these together, I'm not going to do the color changing here. These eliminate. 30 minus 12 is going to be 18y equals 42 plus 30 is going to be 72. So then I'm going to divide both sides by 18 and get y equals, what's 72 divided by 18? Let me see here. I don't know if that's even. Let me try my calculator here. 4, yeah, it is even. Okay, so I get y equals 4. So that solution has 4 for a y value. Now I'm going to plug 4 back in. I'll do it into the second equation. Put in 4 for y. 3x plus 24 equals 6. I subtract 24 off both sides. I get 3x equals 6 minus 24 is going to be a negative 18. Then I'm going to divide by 3 on both sides and get x equals negative 6. And again, you can check on your own.